Hey guys, the objectives with this video is to do a very basic dead and live load calculation. So we're going to be given a section from a general office. So say we have this slab and a beam like this. Okay. Now I've drawn in blue the pressure, which is due from self-weight superimposed in live. We saw in the previous video that we're going to be working out an equivalent line line load from the slab. So we're going to get this pressure from this slab and work out an equivalent line load. And then also we're going to be working out the line load from the beam. Okay. Just to show you plan view, it's 1200 by 600. This is in millimeters. This would be a section through 100, 300, and 200 there. Okay. We're given the density of concrete as 2500 kilograms per meter cubed, and we're told that the superimposed dead load is 1 kPa. Okay, so the first thing we're going to deal with is the slab. Now, we're going to first work out the dead load G in the slab. Now, the dead load, as we said in the previous video, is comprised of self-weight of slab and superimposed dead load of the slab. So, dealing with the self-weight first, that component first. The self-weight, as we discussed in the previous video, is the area times the density times the gravity. Okay, and we spoke about how to work out that area. So in this case, it's area times rho times G. The area is going to be 0.1 by 0.6. I'm working in meters and kilograms throughout this video. Okay, so we want to go from an area load, a pressure in blue, to a line load in red. So the dimensions we multiply by, as I said, we exclude the dimension which is parallel to the line load. So in this case, the length 1200 we want to exclude. Okay, we're going to multiply by 100 and 600 there, and that will give us the line load. Okay, so you can see it's 0.1 by 0.6, 0.1 by 0.6 for the slab in meters, times by density, which is 2500, times by G, which is 9.81 meters per second squared. Okay, so unit-wise, it would look like this. We would be left with kilograms meter per second squared times by 1 on meter, which is newtons per meter. So working this out, we have 0.1 by 0.6 by 2500 by 9.81 gives us 1471.5. Okay, now that's in newtons per meter. I'm going to write it in kilonewtons per meter, so we divide by 1,000. We divide newtons, there's 1,000 newtons in a kilonewton, so divide by 1,000 would give us 1.47 kilonewtons per meter. Okay, so that's from the self-weight. Now for this superimposed dead load, we spoke in the previous video how it's pressure times length, and that length is the perpendicular length to the line load. So it's going to be the superimposed pressure is given as 1 kPa, and the perpendicular length, so we want our line load going like this so we can work out what it is in the beam. So the perpendicular length would be the 600. Multiplying by the 600 would give us a UDL in that direction. Okay, so the pressure is 1 kPa, the length is 0.6 meters, so unit-wise kilonewtons per meter squared. We spoke about how a kPa is the same as a kilonewton per meter squared. Times by meter gives us kilonewtons per meter. So 1 times 0.6 is just 0.6 kilonewtons per meter. Okay, now we can work out the total dead load. We said that the dead load is the addition of self-weight plus superimposed dead load. So working this out, 1.47 we saw over here, and 0.6 we just worked out now. Adding those together would give us 2.07 kilonewtons per meter. Once again, this is just the dead load. Step 2 is now going to be finding the live load in the slab. Okay, now because this is given to us as a general office, we're going to go to table 3.1 on page 9. So if I go to table 3.1 on page 9, this is in AS 1170.1. So we have over here, okay, if we look in table 3.1, if we go to B, we see offices. Let me just zoom in for you guys. Okay, so we have B, offices and work areas not covered elsewhere. Okay, A was domestic and residential activity, so we're not domestic and residential. We are offices and work areas not covered elsewhere. So if we look at this, it says offices for general use, which is ours. It's just a general office. We're given a uniformly distributed action, kPa, of 3. Okay, so 3 kPa. So let me zoom out. So So we know that now our pressure is 3 kPa as told from the table, and we want to multiply that pressure just like we did for the superimposed dead load by the perpendicular length. So it's going to be 3 kPa times by this length there, 0.6 meters, will give us a UDL in this direction along parallel to our beam. So 3 by 0.6 gives us 1.8, so 1.8 kilonewtons per meter. Okay? Now, we can then work out the beam. Okay, so for the beam. Now, because we've worked out the dead and live load for the slab, we are just going to work out the dead load in the beam. Okay, you don't work out the live load twice, if that makes sense. We've worked out the dead and live load in this beam. Now we're just going to work out the dead load, the dead and live load in this slab. We're now just going to work out the dead load in this beam. Okay, so step 3 is the dead load in the beam. It's the exact same procedure. It's just the self-weight of the beam. There's no superimposed. Okay, the superimposed was, say, the carpet on the slab. We've already worked that out. That's going to be transferred into the beam. Okay, so we don't need to double up. Now, just like before, it's area times density times gravity. Okay, and obviously the same procedure. We want a UDL going the length of the beam. So the area we're going to multiply by is we're going to exclude the length parallel to that load. So we're going to exclude the 1200. It's going to be 0.2 by 0.3 will be the area. Okay, so 0.2 by 0.3 meters times by the density of concrete, 2500, times by gravity, working that out. So 0.2 by 0.3 by 2500 by 9.81 gives us 1.1471.5. Okay, dividing through by 1000 gives us 1.47 kilonewtons per meter. All right. Now, as I said, there's no need to do superimposed dead load or live load again, as it has been considered in the slab. Okay, so this is all transferring. All the load's going to be transferring from the slab into the beam. Okay, so you don't need to do it again. So for the total system, the total load in the beam now will be the dead load of the slab plus the live load in the slab plus the dead load in the beam. Okay, so it's going to be 2.07, which was our dead load in slab, plus 1.8, which was the live load in slab, plus 1.47, which is dead load in beam. Okay, working this all out, we get 5.34 kilonewtons per meter. Okay, I'm just going to reiterate this one point, that because we've worked out the dead and live load in this slab, that's now just transferring into this beam. Okay, so we don't need to work out superimposed or live load again for the beam. All right, because as you can see, we have a line load from self-weight of beam and a line load of self-weight and superimposed and live load in the slab, which we just add up together in the end to give us one total UDL through the beam from slab and beam. Okay, I hope that point's quite clear. Anyway, guys, we're going to move on to a bit more theory in the next video, but after that we're going to be doing a very comprehensive example of a structure, working out a whole bunch of stuff. Anyway, guys, hope that helps, and we'll see you in the next videos.
Cut study time with concise video summaries by top students. Visit spoonfeedme.com to view more free videos in this course and hundreds of others.